So we're officially opening the webinar for today. So welcome for this third episode of the React Cluster webinar series. The topic of today will be from data to decisions, how can AI and big data support decision-making in resource recovery from waste? I will be moderating today's session. I'm communications coordinator within ISWA and the iBot for CRMS project. During the webinar of today, we'll have 4 experts with us from various EU-funded projects. So we'll hear about Michail Maniadakis from Reclaim, Petri Kannisto from ALCHIMIA, Antonio M.Ortiz from iBot for CRMS, and Cesar Prado from DARROW. They will go over the different applications from solid waste to scrap steel to waste from electrical appliances and electric vehicles and wastewater, and explore how can data-driven tools and AI technology are reshaping the future of industrial decision-making and are being leveraged to boost efficiency and sustainability and waste and resource recovery. So we will be together for about an hour and a half until 12:30. This is the webinar introduction that you see on the slide. We will then go over the 4 different presentations by the experts of today. So they will have each about 7 minutes presentations. And then the second part of the webinar would be an interactive panel discussion on critical questions around the topic of today. We will have time, about 10 minutes at the end of the webinar for Q&A from you. And then we'll conclude for about 5 minutes. Before I introduce the speaker of today, the first one, I would like to run through a few technicalities. So as you can see, the meeting of today is being recorded. So it will be made available on the different projects channels afterwards. So I invite you to follow these different channels to be made aware when the recording is available. I will share with you in the chat the details a bit later on. And then today we will be using Slido to essentially just gather in 2 different moments your input. So the first question is, we're going to go through it now. So if you would like to scan the QR code on the screen or go over to slido.com, I will switch screens and then go over to the Slido presentation for the first question of today. Which is, we would like to know which type of organization do you represent, if it's either research and academia or process industry companies, technology providers, recycling companies, manufacturing companies, industrial associations, European partnerships, more like policymakers and regulatory bodies, or civil society and media. So it looks like from now, research and academia is the majority. So I will leave this open for maybe a couple minutes so that you can see. I hope you had time to also log in. You also have the QR code on the side if ever, you didn't. But so far, okay. So we also have policy present here today. So this is essentially to have an idea on, who is present in the room today. Okay, technology providers, industrial associations. So it's very varied, actually. Recycling companies, very nice. Okay. So I will leave the Slido open for a few more seconds, so then we can also have this information later on. I invite you to continue voting, and then I will go back to the presentation quickly to jump over. So here we go, up. So the first part of this webinar would be essentially to go over different presentations by experts. So the first expert of today is Michail Maniadakis. He's a researcher and he's working at the Computational Vision and Robotics Laboratory at Force ICS. He's specialized in machine learning and cognitive robotic system, and he's been pursuing research for about 20 years. And he's currently the coordinator of the Reclaim project. So without further ado, Michail, I'll give you the floor, and you have about 7 minutes for your presentation.
Are I supposed to hear something now?
Yeah, can you maybe unmute? I cannot click on my side, but you should have the button, Michalis.
Okay, yes,
yeah,
yes.
Perfect, perfect.
Can you see my screen? Okay,
Yes.
okay. So sorry for this confusion. Sorry. So yeah, I'll discuss about the Reclaim project and how we treat big data for our AI purposes. The full title of the Reclaim project is an AI-powered portable robotic material recovery in a box. This is a project that is implemented by 10 partners coming from 5 different countries. And regarding the problem that we're going to address in Reclaim, this is focused on the waste that we all as citizens produce. And what happens with this waste is that they are collected and they are transported into central places, material recovery facilities. These are the MRFs close to the urban areas. And there they are processed in order to recover valuable materials. This happens either manually or automatically, but this is not a big issue here because the centralized model that we follow up to now is not efficient for remote areas and for sites where high volume of waste is produced in a very short time. The reason why this is not efficient is because it is very costly to transport the waste to the central MRFs. The waste is usually compressed inside trucks, so this makes the recovery of the sorting of materials more difficult, and at the end we have less materials recovered. So there is a need for a portable material recovery facility, and this is exactly what we are doing in Reclaim. We are developing a low-cost and portable and robotic material recovery facility that is able to sort waste at a local scale, but with an industrial level efficiency. And this is more cost-effective, mainly because we save a lot from the transportation to the central MRFs. This video shows what happens inside this MRF, the container that is full of technology, robots and cameras and AI. You see that there are 5 different robots installed inside the PRMRF that they can pick and sort waste into different bins depending on their material type. To make this real and more efficient, actually, we have developed our own robots, which are some very low-cost robots that are doing the picking and the sorting of the waste. These are linear robots with either 1.5 degrees of freedom or 2.5 degrees of freedom. The 0.5 degree of freedom refers to a piston that moves up and down with a binary mode, and you see that things can run quite efficiently. Now, regarding the decision making, we collect a lot of images from waste images that are processed and are used to train our models in order to be able to categorize, identify and categorize the waste objects. An example is shown in this figure. We want to categorize objects as PETs, aluminum cans, or HDP bottles. You understand that the waste images are actually endless. There are different deformations that they may have is endless. So what we do instead of recording millions of images, we are also trying to produce our own synthetic data. And this is what is shown here. We start from an original image on the left, and then we do random transformations in order to produce new ones, new appearance of this object. We have trained a model that can assess the realism of the produced images, and you see that on the right, we can develop new, quite realistic synthetic images. that are used to train our models. On top of that, there is also the option of having a dual spectrum categorization, which means that we can categorize the waste in both the visible domain and the infrared domain. This increases a lot the accuracy of our decisions. And in fact, what happens is shown in this video. You see that by combining the two, actually both categorization approaches have their pros and cons. So by combining the two, we can have at the end a very highly accurate decision-making procedure that goes up to 98.5% of accuracy. Overall, the container that we have developed is a full system that can be easily transported and deployed in less than an hour. The video shows here what our participation in an exhibition where the whole container was transported and be ready to operate in less than an hour. The PRMRF that we're developing can recover up to 7 different material types. The ones that are shown in this slide: PET, PE, PP, polystyrene, 3 cartons, aluminum, and ferrous metals. Regarding this performance, it can pick on average 120 items per minute, which overall goes to more than 50,000 items recovered per shift. And this is the system that actually next week we will start processing waste in Kefalonia Island. I mean, these are real waste that are produced by the citizens and the visitors of the island. So we will be in contact with the real demands of waste sorting. The image on the right shows what happens now in the island. So the whole waste stream is collected and transported to the mainland for processing. This means that we transport both the recyclables that have a value, but also the residue. And after processing, the residue have to go back to the island for land filling. I think that you can understand that this is quite costly, but this is not the worst that we have experienced up to now. This figure shows what happens in the Pacific Islands, where they use airplanes to transfer their waste in central places for processing. So this clearly shows the need for a small-scale waste processing unit. That is the one that we are implementing in Reclaim. And with that, we believe that we propose a new model of the circular economy that is based on the decentralized waste processing, small and local scale. And what we achieve is industrial level efficiency for sorting waste, much less transportation of waste. We believe it improves the material recovery because the waste does not need to be compressed, and clearly this creates opportunity for new businesses and new jobs. That was all. Thank you for your attention, and yeah, we may go. Thank you.
Thank you, Michalis.